Have you ever wondered how many eclipses occur on Jupiter each year? Eclipses, you see, are not simply an earthly spectacle. They happen all across the vast expanse of our solar system, each with its own unique pattern and frequency. Now let's focus on Jupiter, the behemoth of our solar system. With its enormous size and a whopping 67 moons, Jupiter presents a fascinating stage for the dance of shadows we call eclipses. Just imagine the sun's rays, journeying across millions of miles, only to be blocked by one of Jupiter's moons, casting a shadow on the gas giant's surface. But these Jovian eclipses aren't just larger. They also differ from the ones we witness here on Earth. That's partly due to Jupiter's unique characteristics, including its size, its distance from the sun, and its multitude of moons. Stay tuned to find out just how many eclipses Jupiter experiences and why. So, what causes these celestial spectacles on the gas giant? Well, the science behind Jupiter's eclipses is as fascinating as the events themselves. Similar to how our own lunar eclipses occur, these Jovian eclipses are caused by the shadows of Jupiter's moons. But unlike Earth, Jupiter has not one but 3 moons primarily responsible for this phenomenon: Io, Ganymede, and Europa. These moons, like celestial performers, dance around Jupiter in a cosmic ballet, casting their shadows on the gas giant's surface and creating a spectacle of eclipses. But what makes Jupiter a hotbed for these astronomical events? The answer lies in the size of the moons and their proximity to Jupiter. Let's take a closer look. Ganymede, the largest moon in our solar system, casts a sizable shadow on Jupiter, often causing total eclipses. Europa, slightly smaller but closer to Jupiter, creates partial eclipses with its shadow. Io, the most inner of the 3, orbits so close to Jupiter that it casts frequent but fleeting shadows, causing short-lived but regular eclipses. The size of these moons and their closeness to Jupiter, coupled with the planet's rapid rotation, contribute to the frequency and duration of these eclipses. In fact, the rapid rotation of Jupiter, a day on Jupiter lasts less than 10 Earth hours, means that an observer on the planet would see these shadows transit across the surface at a brisk pace. But it's not just about size and proximity. The orbits of these moons are also crucial. They are locked in what's known as a resonance, meaning they orbit at speeds that are simple multiples of each other. This regularity and predictability make for a near constant cycle of eclipses on Jupiter. So in essence, the science behind Jupiter's eclipses is a symphony of cosmic factors: the size and proximity of the moons, their orbital resonance, and the rapid rotation of Jupiter itself. Now that we understand the how, let's explore the how often. You might be surprised to learn just how often Jupiter is plunged into darkness. This colossal planet, the largest in our solar system, experiences an astronomical number of eclipses each year. Why such a high frequency, you ask? Well, it's all thanks to Jupiter's 4 large moons and their orbits. Unlike our lonely moon here on Earth, Jupiter is orbited by 4 substantial satellites known as the Galilean moons. These are Io, Europa, Ganymede, and Callisto. Each of these celestial bodies orbits Jupiter at a different speed and distance, resulting in a staggering number of eclipses. We're talking about thousands of eclipses each year, folks. This is a stark contrast to our earthly experience. Here on Earth, we're lucky if we get to witness a handful of solar and lunar eclipses each year. That's because the alignment of the sun, earth, and moon required for an eclipse is relatively rare. So, Jupiter's sky is a constant dance of light and shadow, but what types of eclipses can we observe there? On Earth, we're familiar with solar and lunar eclipses, but what about on Jupiter? Well, Jupiter experiences 2 distinct types of eclipses. The first is a transit. This occurs when one of Jupiter's moons passes between the planet and the sun, casting a shadow on Jupiter's cloud tops. It's like a small dark spot zipping across the face of the gas giant. The second type is known as an occultation. This happens when a moon disappears behind Jupiter or slips into its shadow. Just imagine, one moment you see a moon orbiting Jupiter, and the next, poof, it's gone, hidden by the immense size of the planet or shrouded in its shadow. These eclipses on Jupiter, both transits and occultations, provide a captivating display of celestial mechanics. They remind us of the wonders of our solar system and the intricate dance between light, shadow, and planetary bodies. So, next time you look up at the night sky, remember that eclipses are not just an earthly spectacle, but a Jovian one too.